Artemis I, November 16th, 2022. The Space Launch System lifts off from Kennedy Space Center at 1:47 in the morning. It is the first launch of NASA's new moon rocket, the vehicle designed to return humans to the lunar surface for the first time in 50 years. The Orion capsule at the top of the stack is uncrewed. This is a test flight. Everything about it is supposed to be understood. 25.5 days later, Orion re-enters the Earth's atmosphere at 24,500 miles per hour. The heat shield, designed to protect a crew from temperatures reaching nearly 5,000 degrees Fahrenheit, does its job. Orion splashes down in the Pacific. The mission is declared a success. 3 months after splashdown, NASA's post-flight inspection team completes its analysis of the heat shield. What they find is not in the press release. It is in the technical report. NASA's own engineering technical report, filed by the Artemis I heat shield anomaly Tiger team, documents what the inspection revealed. The heat shield ablator, a material called avcoat, had charred and cracked in ways the pre-flight models did not predict. Chunks of ablative material had broken away during re-entry in a pattern the engineers described as unexpected. The word used in the report is anomalous. That report was not published on the day of splashdown. It was not published the week after. It emerged in 2023 after independent researchers and journalists began asking why Artemis II, which was scheduled to carry 4 astronauts on a lunar flyby, had been pushed back from its 2024 launch window. NASA confirmed the delay. The stated reason was the heat shield anomaly. What the statement does not say is what the anomaly means for a crewed mission. What it does not say is what the inspection found in the specific regions of the heat shield that face the highest thermal loads on the return from lunar distance. What it does not say is whether the anomaly was worse at lunar reentry velocities than at standard orbital reentry velocities, and whether that difference changes the calculation about sending people around the moon. Those questions are in the official record, in the gap between what was found and what was explained. The gap is still there. I want to walk through what the record actually says. The Orion spacecraft uses a heat shield made of avcoat, a material originally developed for the Apollo program in the 1960s. It is an ablative heat shield, meaning it works by burning away in a controlled manner. The outer layer chars and erodes, carrying heat away from the spacecraft through the process of ablation. The key design parameter is that this erosion happens predictably, uniformly, in a pattern the engineers have modeled and tested and validated. On Artemis I, it did not happen uniformly. NASA's own post-flight documentation describes regions of the heat shield where the avcoat charred more deeply than the models predicted. In some areas, the material cracked. In some of those cracked areas, chunks of the char layers separated from the underlying material and were lost. This is called spallation. The models did not predict spallation. Spallation during re-entry from lunar distance, at velocities and thermal loads significantly higher than those experienced during low Earth orbit returns, had not been observed in the program's pre-flight testing. The Artemis I mission report, NASA's own document, confirms this. The heat shield performed adequately for an uncrewed test. The question the report does not answer is whether adequate for uncrewed is the same as adequate for crewed. That question matters at lunar return velocities specifically. Orion returning from the moon enters the atmosphere at approximately 24,500 miles per hour. The space shuttle, returning from low Earth orbit, entered at approximately 17,500 miles per hour. That difference in speed translates to a difference in thermal load on the heat shield that is not linear. The heat generated scales roughly with the square of the velocity. You are not just going faster. You are hitting the atmosphere with substantially more energy. The shield has to absorb more. The margins, whatever they were in testing, have to hold at the higher load. The Artemis I data shows that the shield did not behave as modeled at that load. The models were wrong in their predictions. The models are the same models that will be used to certify the shield for Artemis II, which will carry Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen around the moon. The Tiger team reviewing the anomaly recommended a series of additional tests and analyses before committing to the crewed mission. Those tests were conducted. The results were fed into a revised certification baseline. Artemis II was delayed from 2024 to April 2026 as a result of this process. Then it was delayed again. As of the information available, the launch is currently targeting late 2025 or early 2026, pending the outcome of the certification review. The certification review is ongoing. The public record of what that review has found, specifically what the revised models now predict for the crewed mission's re-entry, is not publicly available in detail. That is not unusual for a program still in active development. What is unusual is the specific nature of the anomaly they are working around. Spallation of a heat shield on a crewed spacecraft returning from the moon at 24,500 miles per hour is not a margins problem. It is a failure mode problem. If chunks of the ablative layer separate at the wrong time in the wrong location, the thermal protection at that location is reduced. The heat penetrates deeper. On an uncrewed capsule, that is data. On a crewed capsule, it is something else. I am reading the report. The report describes the anomaly. The report describes the investigation. What the report does not describe in terms available to the public is a complete mechanistic explanation for why the spallation occurred, why the models failed to predict it, and whether the revised models are now correct, or whether they have simply been adjusted to fit the observation without a first principles understanding of the failure. That distinction is important. A model corrected because you now understand the mechanism is more trustworthy than a model adjusted because the data surprised you. The report, as published, does not make clear which of these has happened. There is a second anomaly in the Artemis I record that sits alongside the heat shield finding. It is not about the heat shield. It involves the trajectory orbit around the moon. The capsule traveled approximately 40,000 miles beyond the far side, further from Earth than any spacecraft designed for human habitation had ever traveled. The distant retrograde orbit was chosen partly for mission architecture reasons, and partly because it is gravitationally stable. A spacecraft in a distant retrograde orbit around the moon stays there without continuous propulsion. During that far-side pass, the portion of the mission when Orion was beyond the limb of the moon and out of direct communication with Earth, the spacecraft's systems operated autonomously. The onboard computers managed attitude control, power, thermal management. The mission proceeded. After Artemis I, NASA published a summary of all anomalies encountered during the flight. The document runs to several hundred line items. Most are minor, valves that took longer to actuate than expected, sensors that read slightly outside their predicted ranges, software flags that triggered without consequence. One item in that log is different in kind from the others. During the distant retrograde orbit, Orion's star trackers, the optical instruments that determine the spacecraft's orientation by identifying stars, experienced a period of degraded performance. The official characterization is that the star trackers were affected by stray light. The corrective action taken was a modification to the attitude pointing profile, a change in which direction the spacecraft was pointed at specific points in the orbit. That modification is described in the anomaly log as an in-flight workaround. I want to be precise about what this means. Star trackers are critical navigation instruments. If they cannot determine orientation accurately, the spacecraft cannot know where it is pointing, which affects antenna alignment for communication, solar panel alignment for power, and thruster direction for orbital corrections. A period of degraded star tracker performance in a distant retrograde orbit around the moon, resolved by changing the spacecraft's attitude, means that the original attitude profile did not account for the light environment in that orbital regime. The light environment in a distant retrograde orbit around the moon is different from anything the spacecraft had been tested in. The geometry of sunlight, moonlight, and earthlight at 40,000 miles beyond the far side is a combination that cannot be fully replicated in ground testing. The models predicted something. The models were surprised. The anomaly log entry characterizes this as resolved. The workaround was implemented. The mission proceeded. The star trackers recovered to nominal performance. What the anomaly log does not describe is whether that same light environment and that same star tracker behavior will recur on Artemis II, which will follow a trajectory similar to Artemis I, and whether the attitude modification has been incorporated into the Artemis II mission profile, or whether a different trajectory was designed partly to avoid the regime where the star trackers struggled. NASA has not published the Artemis II trajectory in the specificity that would allow that question to be answered from public data. The title of this video uses the phrase "changed course." I want to be exact about what that refers to. There are two documented trajectory-related decisions in the Artemis program record. The first is the in-flight attitude workaround during Artemis I's distant retrograde orbit. The second is the delay of Artemis II, which restructured the mission timeline, and in doing so, changed the launch windows available, and, consequently, the specific trajectories available for the crewed mission. Whether the trajectory for Artemis II was adjusted to avoid the orbital geometry that caused the star tracker anomaly, that is not in the public record. It is a question the public record creates and does not answer. I want to move to the named source element of this, because there is a specific documented statement that belongs here. In July 2023, NASA's Associate Administrator for Exploration Systems Development, Jim Free, testified before the Senate Commerce Committee's subcommittees on aviation, space, and science. The subject was the Artemis program's progress and the implications of the heat shield finding. This is a public congressional hearing. The transcript is available. Senator Bill Nelson, himself a former astronaut who flew on the space shuttle in 1986, asked Free directly about the heat shield anomaly and its implications for crew safety. Free's response in the hearing transcript acknowledged the anomaly and committed to completing the investigation before flying crew. He used the phrase, "We will not fly until we understand it." We will not fly until we understand it. That is a precise statement from a NASA official, on the record, in a congressional hearing, about a specific anomaly on a crewed spacecraft. As of the information available at the time of this research, that understanding has not been published in a form accessible to the public. The certification review continues. The characterization NASA has offered is that the review is proceeding and that confidence in the heat shield for the crewed mission is high. That confidence has not been grounded publicly in a mechanistic explanation of why the Avcoat behaved the way it did. We will not fly until we understand it. That statement is in the congressional record. The explanation of what they now understand, if that understanding exists and has been reached, is not in the public record in any equivalent level of detail. I want to document the silence precisely because the silence here is not a refusal. It is an absence. Jim Free did not go before the Senate and then stop talking. He has continued to make public statements about the Artemis program. Those statements characterize the program's readiness in terms of confidence and progress. They do not contain a published mechanistic explanation of the heat shield failure mode. The gap between "we will not fly until we understand it" and the subsequent characterizations of readiness is not filled publicly by a document that says, "Here is what caused the spallation. Here is the physical mechanism. Here is why the original model missed it. Here is the test that confirmed the revised model. Here is the margin the corrected model now gives us." That document may exist. It may exist inside NASA's program office and not have been published. It may be in a standing review board report that has not been released. I do not know. What I can tell you is that it is not in the public record in the form that Jim Free's testimony was. Those two things, the commitment and its evidentiary basis, are not aligned in what is publicly available. That is what I am documenting, not a cover-up, a gap between a public commitment and a public explanation. Now I want to bring in the parallel program record, because there is one that bears directly on what the Artemis I heat shield finding means for the broader question of returning humans to the moon. The Russian Federal Space Agency, Roscosmos, was a founding partner of the Lunar Gateway project, the orbital station NASA plans to use as a staging point for Artemis surface missions. Russia signed the partnership agreement in 2017. In 2021, Roscosmos announced it was withdrawing from the Lunar Gateway. The stated reason was political, the deterioration of U.S.-Russia relations in the context of the geopolitical situation at the time. That is possible. The political context was real. But consider what happened next. In August 2023, Russia launched Luna 2.5. It was the first Russian lunar mission since Luna 2.4 in 1976, a gap of 47 years. Luna 2.5 was designed to land near the lunar South Pole. The South Pole is where Artemis surface missions are also targeted, because orbital data from multiple missions, including India's Chandrayaan, one which confirmed the detection of water ice in 2008 using NASA's Moon Mineralogy Mapper instrument, suggests there is water ice in the permanently shadowed craters at the poles. Water ice is a critical resource for any sustained human presence on the moon. It can be converted to drinking water, oxygen, and rocket propellant. Luna 2.5 did not land near the South Pole. It crashed. Roscosmos confirmed the crash on August 20, 23. The official explanation was that the spacecraft's propulsion system fired longer than commanded during an orbital correction maneuver, sending it into an uncontrolled descent. That explanation is plausible for a spacecraft program that had been in abeyance for nearly 5 decades. A 47-year gap in operational experience is a real technical risk. But here's what sits next to that explanation in the record. Luna 2.5 was attempting to image the South Polar region, specifically the terrain around Boguslavsky crater and the Aitken Basin approach, during its pre-landing orbital phase. It was collecting imagery and surface data in the days before the crash. That data was being transmitted to Roscosmos. What that data contained has not been publicly released. Roscosmos did not publish the pre-crash imagery from Luna 2.5's descent orbit in the weeks and months following the mission's failure. The stated reason for this has not been formally given. There are 2 published Russian scientific papers from researchers affiliated with the Luna 2.5 science team that were submitted in the period following the mission's loss. Neither of them discusses findings from the mission's operational phase. They discuss the mission's objectives and its design. They are pre-loss papers submitted post-loss. The data from Luna 2.5's orbital phase, whatever it captured before the crash, is not in the public scientific literature. This is the parallel I want you to hold. The United States designed a crewed lunar return program. The crewed test flight produced a documented heat shield anomaly that has not been fully explained in the public record. The program was delayed. The explanation for the delay, beyond the anomaly's existence, has not been published in mechanistic terms. Russia attempted its first lunar mission in 47 years. The mission crashed. The pre-crash data from the orbital phase has not been published. India's Chandrayaan-3 landed successfully at the South Pole in August 2023, 4 days after Luna 2.5 crashed. It operated for approximately 2 weeks before entering sleep mode as the lunar night began. It did not wake up after the night. The data it returned during its operational period has been published and is being analyzed. The South Pole terrain data from Chandrayaan-3 is now part of the scientific record. I am not drawing a line between these programs and a shared conclusion. I am noting that 3 major space programs, the United States, Russia, and India, all focused on the lunar South Pole in 2023. That one crashed. One partially succeeded, and one is facing a documented anomaly that has delayed a crewed mission. The South Pole is interesting. The water ice is documented. The orbital data that identified it is published. The question of what is in those permanently shadowed craters, what the surface is actually like, what the subsurface contains, is exactly what Artemis's surface missions are designed to answer. The crewed missions have not gone. Now I want to address the official explanation for the Artemis II delay specifically, because I think it is important to engage it fairly and precisely before saying where it falls short. The official explanation is the heat shield anomaly. NASA has been transparent to the extent of acknowledging the anomaly publicly, confirming its investigation, and committing not to fly crew until it is resolved. The Tiger team was stood up, the analysis was conducted, the revised certification baseline was developed, the delay was implemented. These are all real institutional responses to a real technical problem. That explanation is coherent. It accounts for the delay, it accounts for the additional testing, it accounts for the restructuring of the mission timeline. What it does not account for is the specificity of the mechanism. NASA has characterized the anomaly as unexpected and as requiring investigation. The investigation has not produced, in the public record, is a complete account of why the Avcoat behaved the way it did under the specific thermal load of lunar return, not in a form equivalent to, say, the Challenger investigation's public documentation of the O-ring failure mode, or the Columbia investigation's public documentation of the foam strike and its thermal consequences. Those investigations were conducted after losses. I am not suggesting that the standard for Artemis I's heat shield investigation should be the same as a post-accident board. I am noting the difference in the depth of public documentation and asking what that difference implies for the public's ability to evaluate the claim that the anomaly is now understood. The experiment that would resolve the residual question definitively would be a crewed re-entry from lunar distance with instrumented heat shield panels, sensors embedded in the avcoat that transmit temperature and structural data in real time during ablation. That instrumentation would tell engineers, with direct measurement rather than post-flight reconstruction, exactly where and when and why the spallation occurred. Whether Artemis II's heat shield will carry that instrumentation has not been confirmed in the public record. The crewed mission is proceeding. I want to be precise about where I am landing with this. I am not telling you Artemis II is going to crash. I do not believe that, and I am not telling you NASA found something on the lunar surface that caused them to change the mission. The title of this video invites that reading, and I want to be clear that I am not making that claim. I am not telling you the Artemis program is a fraud, or that the astronauts assigned to Artemis II are in danger because of a deliberate institutional decision to ignore risk. What I am telling you is specific and documented. NASA's own post-flight report on Artemis I documents a heat shield anomaly, spallation of the ablative material in patterns the pre-flight models did not predict. That is in the published technical record. A senior NASA official testified before the Senate in July 2023 that the agency would not fly crew until it understood the anomaly. That statement is in the congressional record. The mechanistic explanation for why the anomaly occurred, the first principles account that would allow an independent evaluator to assess whether the revised certification baseline is adequate, has not been published in the public record at a level of detail comparable to the commitment that preceded it. Jim Free said, "We will not fly until we understand it." He said that in 2023. Artemis II is currently scheduled to fly. What sits between that commitment and this schedule is not publicly visible. Russia's Luna 2-5, targeting the same south polar region as Artemis surface missions, crashed in August 2023. The orbital phase data collected before the crash has not been published. Those two facts, the American heat shield anomaly and the Russian data absence, are from different programs pursuing the same destination. They are not connected by any documented link. They are connected by the destination and by the common outcome of information that stops before it becomes public. I find that combination difficult to explain entirely on its own terms. The Artemis I mission report is publicly available on NASA's website. The heat shield anomaly Tiger Team's findings are documented. The Jim Free congressional testimony is in the Senate's public record. You can read all of it. The 55-minute reverberation that NASA documented after Apollo 12 in 1969 has not been explained in the published literature for 55 years. And now, in the program that is supposed to return humans to the moon for the first time since Apollo, the heat shield on the test capsule did something the models did not predict. And the explanation for why it happened is not yet in the public record in a form that makes Jim Free's 2023 commitment fully legible. Two different eras, two different anomalies, one destination. The question the destination keeps generating, what happens when you actually go there, continues to produce official records that contain findings without complete explanations. I do not know what Artemis II will find. Nobody outside the program does. What I can tell you is that the record of what Artemis I found, on the way there and back, contains a documented anomaly and a documented commitment and a gap between those two things that has not been filled in public. That gap is still open. Artemis II is scheduled to fly into it.